take 120?
All right. We are about to begin. All right. Good evening. Dr. Dale Partin ended up spending his entire presentation in January answering your questions about various aspects of the formation and natural history of the moon. So tonight he is going to deliver part 2, which includes the human side of the story and our visits to the moon. Dr. Dale Partin is an amateur astronomer. He teaches astronomy at Macomb Community College here. He has bachelor's and master's degrees in physics and a Ph.D. in electrical engineering from Carnegie-Mellon. Until his partial retirement, and he's still the most busy retiree that I've heard of, he did advanced research in the auto industry. He has over 80 scientific publications, 38 patents, and is a fellow of the American Physical Society and a member of Sigma Psi and of the American Scientific Affiliation. Until his partial retirement, he was also a member of the Institute of Electrical and Electronics Engineers, the Society of Automotive Engineers, and the American Vacuum Society. And I don't think that's the kind that you roll on the floor. His interests include astronomy, archaeology, and biblical studies. And without further ado, I give you Dr. Dale Partin.
It's now July 1969.
I'll turn on one side.
Okay, all flight controllers, gonna go for landing. Retro. Go. Rhino. Go. Go. Control. Go. Telcom. Go. GNC. Go. Econ. Go. Surgeon. Go. Capcom, we're go for landing. Altitude 4200.
Houston, you're go for landing, over. Roger, understand, go for landing. 3,000 feet. You're looking great.
How you doing, Control? We look good here, fine. How about you, Telcom? Go. Guidance, you happy? Go. Rhino. Go.
2,000 feet, 2,000 feet. Into the ag, 47 degrees. Roger. 47 degrees.
Still looking very good.
Your go. Stop alarm. 1201. 1201. Roger, 1201 alarm.
1201 alarm. Same time, we're go, flight. Okay, we're go.
We're go. Same tide, we're go.
Altitude 1600.
Eagle looking great. Roger, 1202, we copy it. 35 degrees, 750, over diver 23. 540 feet, down at 15. 1050 feet, down at 4. Altitude, velocity light, 8.5 down, 220 feet. Outlook forward, coming down nicely, 200 feet, 4.5 down, 5.5 down. 100 feet, 3.5 down, 9 forward. 875 feet, that's looking good, down a half. 6 forward, 60 seconds. Lights on, forward, forward. 40 feet down, 2.5. Picking up some dust. Big shadow. 4 forward, drift into the right a little. 30 seconds forward. Contact light. Okay, engine stop. We copy you down, Eagle. Houston, Tranquility Base here. The Eagle has landed.
This is Apollo Control Houston at 105 hours.
Now to the flight to Apollo 11.
Yeah, our current plan is to have crew members aboard the Eagle to eat and relax for a little while prior to starting EVA prep, so we won't know with certainty or have a reasonable time back until about an hour before the schedule.
街の通りにはかなり多くの人が見られますが、大多数の人はもちろんテレビを見られるホテルのロビーとか休憩室に集まっています。私たちはパリでpour la première fois près le pied sur la Lune. Les Russes sont loin des villes naturellement, mais naturellement aussi c'est surtout dans les halls d'hôtels, les bars et les appartements que les gens se groupent, c'est-à-dire partout où ils peuvent trouver un récepteur de télévision. Et nous attendons tous.
Während die Welt darauf wartet, dass ein Mensch zum ersten Mal den Mond beträgt.
And the world wake up. July 20th, 1969. It is
is said that 500 million people gathered at TV sets around the world to wait for the first Earthling to set foot on the moon. Countless millions more listened on the radio to the voices from the moon.
This is Neil, radio check. Neil, this is Houston, loud and clear.
Never before had so many people been attuned to one event at one time. The world waited, curious, wondering, aware, like a sleeper wakened in the night by a faraway sound. A moment sensed, more than understood.
Say what? Okay, Neil, we can see you coming down the ladder now. Neil, we can see you coming. Okay, I just checked this. Getting back up to that first step, not even collapsed too far, but it's adequate to get back up. Roger, we copy. Pretty good little jump. At the foot of the ladder, the limb footbeds are only depressed in the surface about 1 or 2 inches. Although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Now it's very fine. I'm going to step off the limb. That's one small step for man, one giant leap for mankind.
That's one small step for man, one giant leap for mankind. Species maintain a space and it is on the moon, of course it is.
Oh.
Sur la Lune, à 22h50 o godzinie 4:17 rano, czasu przelotka Kennedy, astronauta Neil Armstrong.
Let me have a little bit of light, please. How many of you are old enough to remember when that happened?
I was not born.
Yeah.
Sorry to say.
Okay.
I was at Fort Gordon, Georgia.
Well, it's kind of interesting. The first man to speak from the surface of the moon was not Neil Armstrong. It was Buzz Aldrin when he said, "Okay, rockets off." That was him you heard talking as they were going down, reading off their altitude and so forth. So then, you know, it was Neil saying this, and then later it was Neil, although Buzz Aldrin wanted to be the first guy off. I almost think he would have fought for it, except there wasn't room for him to get around Neil.
Wouldn't be surprised.
And I think Neil meant to say one small step for a man.
Yeah. Right.
And
He
he
always said
did.
that.
He skipped the word a by mistake, I think. One giant leap for mankind.
Probably had a lot on his mind, though.
He probably did.
I think I would have dove on it rather than climbed down.
One of the issues, I mean, he stepped down onto one of the landing pads and talked about what he saw, and then stepped off onto the moon. And there had been what I think was a minority of scientists who had speculated that the dust on the moon might be real deep, and not only he would sink in and get smothered like in quicksand, but maybe the spacecraft would. They didn't want to let him get out of the spacecraft for a while and had their finger on, or the thumb on the button to take off again, just in case. Turned out the fine dust was not thick.
They wanted to drop like depth charges to test this
Yeah.
cell.
And incidentally, and leading us into the topic I'm about to go into, some who say that this was all a hoax, that we went to the moon, cite the fact that the dust was not super thick, as some had thought it would be, as evidence that it wasn't really on the moon, right? Well, not everybody thought that the dust would be real thick, but they did put rather wide pads on the bottom of each of the legs that the thing was on to try to give it more support, because they couldn't be sure. So, did we go to the moon, or was it faked? That's a question I'd like to address, and I'm not the world expert on this topic, and I'm somewhat nervous about getting into it, because some people who think we didn't go to the moon are real firm believers that we didn't go to the moon. It's all a conspiracy.
For what purpose?
I just met a guy from Saudi Arabia over at Oakland University, and he was convinced. Not only that we didn't go to the moon, he was telling me the Earth is flat. I'm not. He is fighting for this with me, and he's a middle school teacher over in Saudi Arabia. I said to him, "Look, I've measured the diameter of the Earth. You know, you're talking to a physicist and an astronomer, you know." And I start giving him arguments why the Earth is not flat.
You need to tell him he can measure it too.
And nothing I could say was going to change his mind. Nothing.
What's he based
Truth had spoken, and he was the one speaking it, you know. Did somebody say something?
Yeah, I mean, how do you,
We're going
how do
there.
you just ignore everything?
Yeah. As, it might have been Buzz Aldrin once said, if the Earth is flat, then the edge of the Earth would be a super popular vacation spot, right? Everybody'd want to go, and what's down there?
If the Earth was flat,
Turtles all the way
cats
down.
would have pushed everything off by now.
There's this other theory that the sun actually rotated around the Earth. And that's why it
Yeah.
rose and set.
Okay, one more comment, then I'll get into this. Go ahead.
Well, the proof that the Earth is not flat is the existence of cats. If it was flat, everything would be pushed off the edge.
Okay, well, look, I'm going to jump into this topic, and I hope I don't sink into quicksand. We'll see how it goes.
Or moon dust.
Dale, I do want
There's
to
a
point
way
out
down
that
under,
several
so-
autonomous landers did not sink into quicksand, so
Yeah,
you shouldn't
sure.
either.
Sure. I think the view that there was super thick dust was a minority view, okay? Among whatever you call geologists who talk about the moon.
Selenologists.
Selenologists.
They seem to think the astronauts seem to regard the main guy for that as a crank.
So, here we go. Here's a picture of Buzz Aldrin,
Oh my gosh. Could have edited it.
Apollo 11 on the surface of the moon, supposedly. In the above picture, why does it look like the flag is waving? And if you look at the video, it is waving a little bit. Well, why? Okay?
It's obviously.
Yeah, there's obviously a strong breeze blowing that way, keeping it stretched out, right?
I knew it was on
And everybody knows there's no air on the moon, right? So how can that be? And for one thing, there's a rod going this way holding the flag out, not what a flag normally has. And this pole was a lightweight, I think, aluminum tube. And so it had a lot of flex in it. So when you when you push it down, it's going back and forth. And there's no air to damp the motion back and forth of the cloth. and the gravity is reduced, so there isn't as much gravity pulling it down straight. So it could wave around for a little while, right?
That though, that's made to look.
Yeah, it's made to look like that. Yeah, I know. So that's kind of the story, the response to the criticism, why does it look like the flag is waving? I've sure heard this one. Why is there not a blast crater under the rocket? Now, if you noticed, I don't know if you noticed, but in the video I showed, they said we're kicking up dust now, right? So why don't you see a crater under the engine there, right? I mean, the answer has the one piece of the answer is that the dust simply wasn't very thick. Maybe a couple inches or something. And that much wouldn't be visible here. You want to see a crater, right? Beneath the layer of dust, the moon is made of fairly densely packed rock. What dust and loose dirt there was kicked up as referenced, and you can see it in the video.
And on the upper left, you can see the movie lights right there.
Yeah, sure.
The prop.
Uh-huh. I would call those reflections
Oh,
of the lens of the
Oh,
camera.
yeah, of course, you have to edit that out.
To go into this, why isn't there a crater in more detail, the rocket that was down here underneath this thing had a thrust that could be anywhere from 1,000 to 10,000 pounds of thrust coming out of here. Okay? At the time, there were, and Neil Armstrong could adjust it as he was flying this thing down to the surface. As they came in for a landing, he was using about 3,000 pounds of thrust. Sounds like a lot. Well, the diameter of the rocket nozzle is 63 inches in diameter. If you figure out the area of a circle with that diameter, it's a little over 3,100 square inches. So the rocket exhausts not the thrust, but the pressure is 3,000 pounds here, divided by 3,100 square inches, roughly 1 pound per square inch. Now, the pressure of air that we're feeling right here is 14.7 approximately pounds per square inch. So this is a small fraction of atmospheric pressure. If you just put, as you walk, each foot you put down, you're generating more pressure than that.
There's another thing.
If you take your weight and divide it by the area of your shoe that's in contact. Yes?
As the exhaust leaves that nozzle, it expands.
Yeah,
So you're not taking that into
It's
account.
actually a little bigger diameter, right? But at a minimum,
Yes.
it's that. So you can make the case that it's smaller than this pressure. Some scientists had worried that if the dust was real thick, a deep crater would be formed. Didn't work out that way. Why is there no visible flame under the lander? In all of the images and videos, sometimes they'd set up a camera and have it take video as the thing was taken off. Why don't you see, flame? Turns out that the type of fuel that was used, which was a mixture of hydrazine and dinitrogen tetroxide, when it mixes together, it ignites automatically and produces a flame that's completely transparent. You just can't see it. Doesn't mean it's not there. Why don't you see stars in the sky? Granted, it's daylight, but we can't see stars in the daytime because the sky is illuminated, right? It's
Atmosphere.
yeah, you can see the blue of sunlight getting scattered down towards us. It makes it too bright to see stars. But why, when the sky is black, don't you see stars? somebody answer this question. Yeah.
If you open up the lens diaphragm wide enough, you'll see stars, but everything in the foreground will be all burned out.
Right. Takes an old film photographer to answer that question.
The astronauts couldn't even see stars with their own eyes looking outside the window of the module because of the sunlight being that bright, unless it was oriented a certain way.
Right. I'm going. You're right. Yeah. So if you want to see stars, you have, as said, you have to open up the aperture and maybe take a little longer exposure. In which case, all of this stuff is totally overexposed bright. Right? And one of the astronauts, I think, remarked that the stars were not remarkable. I don't know if he could see some of the brightest ones or not, but not remarkable.
Well, they weren't twinkling, for one thing.
Well, yeah, but here's the deal. If you're in your house at night with lights on, and you walk outside and look at the sky, it's not going to look remarkable. You'll see the brightest stars. But it takes 5 to 10 minutes before your eyes darken that. And you can see significantly more stars. I've seen this many times. And when you're under sunlight, it's much brighter light than it is the lights you typically have in your house at night. So it really, in a sense, burns out your eye. It actually consumes most of a photochemical at the back of your retina. So you...
Rhodopsin.
Pardon me?
Rhodopsin.
Rhodopsin. We got a medical doctor here to keep me on the straight and narrow. And you deplete that to where you can only see bright things. And then it takes on a 5 to 10 minutes time scale when you go out where it's dark. But they were never out where it was dark. Right? They walk around, you're looking at the ground and stuff, and you glance up, your eyes have no time to darken that.
Can I ask a question? In the last image, there's a brown spot on the Earth.
Looks like Africa.
There's just no clouds above, no clouds.
Yeah, looks like
Here it
Africa.
does.
There's the Mediterranean, the Atlantic, the Red Sea.
Okay.
Most of Western Europe.
The Arabian Peninsula.
What?
Arabian Peninsula, he's right.
The Arabian Peninsula is at the right and left.
Yeah, right there is the Arabian
Okay.
Peninsula.
There's just no
I can
clouds.
kind of see
Yeah.
lower part of Africa there too.
Notice where there are clouds, it's green.
Yeah.
Okay, I'm going to keep going. Why can we see objects in shadow? Like this. Well, why? Okay. Because there's no air up there to scatter light and illuminate like there would be here on Earth. The answer is the lunar surface, although it's not terribly reflective, it is somewhat, I mean, there it is, it's reflecting light. You can see it, right? And light reflected from other parts out where I am standing, if I was there near him, right? That's hitting him and this stuff and illuminating it.
You're taking the picture.
Yeah, I'm taking the picture. In short, moonshine is what is illuminating objects in shadow. I mean, I've watched a lot of videos of people saying that we didn't go to the moon, and they run through these things like there's no answer. Like, see, this proves that we didn't go to the moon, right? I mean, I want to punch them or something. I mean, I don't mind their taking the view that we didn't go to the moon, but I like honesty too.
That's not going
Right?
to happen.
I like honesty too.
I'd like to ask them why it's so important to them that they believe that.
It would be a major conspiracy.
Yeah, it would be a major thing. It would be important to me if I thought we didn't really go.
Well, no, but I mean, in the face, they don't want to accept any evidence, so that puts it beyond
Well,
that.
I'm not speaking about necessarily all of them,
Yeah.
but I have seen some.
Hydrogen and stupidity.
Universal constants.
Anyhow, let's keep going. Why do the shadows point in different directions? This shadow of the spacecraft kind of goes in that direction, slightly up when it goes off to the right. His shadow appears to go down a little bit to the right. Well, the terrain is not level, is what it comes down to.
Their argument is that it's a studio light.
Yeah, they would say there's different lights in the studio pointing in different directions. And you can see the same effect on Earth when the ground is not level, especially when the sun is near the horizon. You can see those kind of effects. And these landings were planned to always occur either just at sunrise on the moon or just before sunset. Bearing in mind it's, takes a month to go from one day to the next on the moon.
Also, cameras, the lenses have characteristic distortion when you take a picture.
Yeah, especially if you use a real wide-angle lens.
Mm-hmm.
I found this objection, I don't know, it was called fried film. The claim was that in the sun's rays, the moon's temperature is a toasty 280 degrees Fahrenheit. The film, among other things, would have melted. The astronauts would have overheated too, so they couldn't have been there. Well, no one was leaving bare film out in the hot lunar surface. All material was contained in protective canisters. They were either near dawn or dusk, so the temperature was more manageable.
What was the temperature?
Well, it varied. And the astronauts, when they would land, like just after the sun came up, they got a camera attached to their chest, to the chest of their spacesuit, and they're walking around, doing various things where sometimes it's in sunlight and sometimes it's not. It takes time for it to heat up or cool down.
So, but like on average, what was it?
Well, it was livable for the astronauts in their spacesuits.
I don't think they had temperature sensors in their cameras, though, and put
Right.
actual temperatures inside the camera.
Or external sensors?
Pardon?
Spacecraft or anything else?
What?
No external sensors?
I don't
outside
know
of
if they had
spacesuit or
external
outside the
sensors.
aircraft?
You mean temperature sensors?
Yes.
It must have.
They must have, yeah.
Could you do that? I mean,
Another thing is
Make it-
footprints. To
Well-
leave a footprint requires moisture in the soil, doesn't it? Okay? Answer, not always. If you take some dry, fine-grained dust, such as talcum powder, and dump it out, it's easy to make tracks in it that hold their shape. The particles hold their positions due to the friction between the particles. You can leave footprints in dry powder. Death by meteor.
Whoa.
The claim, space is filled with super fast micrometeors that would punch through the ship and kill the astronauts. While space is really big, where there are a very large number of tiny pieces of debris flying around at high speed, space is so big that the density of those particles is low. Chance of any given cubic yard of space having a micrometeor passing through it is close to zero. And the astronauts actually were wearing armor, Kevlar armor on their spacesuits. It was integrated with their spacesuits to stop really, really tiny particles if they get hit. The rover was too big to fit on the spacecraft.
Yeah.
Couldn't have done it. It's too heavy and too big. Well, the rover was designed cleverly to be made out of very light materials and designed to fold up very compactly like a transformer. I mean,
do you have a picture?
Yeah, there are pictures of it when it was
Do you
folded
have
up. Huh? No, I didn't get the pictures. The astronauts could not have survived because of large exposure to radiation from the Van Allen radiation belt. On the International Space Station, they're flying at low altitude above the Earth. But going to the moon, you have to go out through these belts of radiation. According to a Russian cosmonaut, that would kill you. Understand, cosmonauts never went out there to check it out.
Because they knew it would kill them.
That's right.
Loved it.
It just sounds like sour
So-
grapes to me, I don't know.
They went through these radiation belts rather quickly. We sort of knew about those belts. The United States was the one that discovered those radiation belts, named after an American scientist
Allen.
named Van Allen, right?
Yeah, Van Allen.
Back in the, I think it was in 1958 that we discovered that, or something like that.
Hit it out of the park, right.
So the short time it takes to go through the belts, combined with the protection from the spacecraft, means that any exposure to radiation would be a little larger than getting a chest x-ray. Granted, they had to go through it twice, once going out and once coming back.
Whoa. We don't have any manned missions that hang around in that belt for any length of time.
No, we don't. In fact, that launch of the SpaceX, what do they call it, the Falcon Heavy, they deliberately had to go out and hang out in one of, I don't know which belt, probably this one, for several hours to test the electronics on the spacecraft and see if they would have problems, and they didn't. They could have, but they were designed to be radiation resistant. Here's one I didn't see, but I thought about when I was reading that other one. Wouldn't the film have been fogged by the radiation in the Van Allen belts? Radiation fogs photographic film. It exposes it. And then when you develop the film, it looks foggy, okay? It's a way of measuring radiation. Back in the early days of doing experiments on cosmic rays, they would use film, okay? X-rays is a form of radiation. When it hits film, you can get a picture of your bones, right?
When I went to the airport years ago and had film, they allowed me to take the film out, not have it go through the X-ray.
Yeah. So if film gets hit with enough radiation, it will fog it. Well, I'm sure they had it shielded. I didn't research that, but it's not hard to do. It's a lot easier to shield a small container with a bunch of film in it than people, because film is smaller. Right?
We have a lead-lined bag that we kept our film in when we went through the airports.
And a lot of rocks were supposedly brought back from the moon. And they've been studied by geologists all over the world. And they confirm that they are what you would expect from the moon, and they show a lot of properties. You can see what kind of radiation they were being exposed to as they were laying on the surface of the moon. It all fits. And, you know, these days you can take pictures of the places the astronauts went down, not from the Earth. This is a NASA picture, so you could argue that, you know, we're asking NASA to check out whether NASA was lying to us. My comment there is an increasing number of countries have lunar orbiters with imagers on them. India, for example. I think they're going to launch another thing to the moon next month, I think. But they launched one 8 or 9 years ago. And other countries are coming soon. And I don't think anybody at NASA is worried that, gee, they're going to see that we didn't really leave footprints and tracks of where people walked and stuff.
Yeah, somebody was able on YouTube, saw this in the last couple of weeks, to match up the view from the ascent stage looking out the window to this picture and match the tracks up.
Okay. Now, the astronauts left some science equipment on the surface of the moon, including, among other things, special optical reflectors. Here's another view of one of them. And so that 3 of the 6 Apollo missions that landed on the moon left those reflectors, and 2 unmanned Soviet rovers had optical reflectors that were actually supplied to them by French scientists. And they have what are called corner cube reflectors. It's not like a mirror where if a beam of light comes in at an angle, it bounces off this way. These things are designed so that whatever direction light comes into them at, it goes back the way it came from. Okay? There's a crude, similar kind of thing on the taillights of your car, so that if the light bulb burns out, there's a car with headlights behind you, those headlights will bounce back in the general direction, at least, of the car behind, so they'll see some red light from your taillights. So, point is that those 5 reflectors, 3 from NASA, 2 from the Soviets, are still being used to measure the distance to the moon. Yes?
Just to be devil's advocate, that being an unmanned mission doesn't mean we landed man on the moon. And I was talking to a friend who believes the conspiracy, and when I said, hey, the reflector that we put on there, he said, well, that happened later, and his belief is that we weren't ready to put a man on the moon in 1969. We did later, but the first one was a fake.
So we faked it in 1969, but we also kept it secret, what, in the 80s or 90s or something? That would be even harder to do.
No, I think she's saying in the 70s maybe we went, late, the early 70s. 69.
Well, we did go in the early 70s.
Yeah.
Well, yeah, so he believed that those happened. It was only the first one he thought was a fake.
Okay, he can think it's fake.
Right.
He can believe in Santa Claus too, Yeah.
Did the Russians actually deliver their own lunar lander?
Yeah.
Yes.
Yeah, I wasn't aware of that. When
For unmanned vehicles.
Yeah.
in the mid-60s before we landed?
Yes.
Oh, okay.
Yeah, we had stuff on the moon too earlier than this.
Okay.
Sure.
I don't recall that any of our stuff had a rover.
No.
But,
did.
but
No,
we
Lunar
did have-
Pod
We had
1 and
rovers
2
on the
were
moon.
rovers.
Yeah, we did.
Did we?
Absolutely.
anyhow,
Not bad.
but it was publicized at the time that the Soviets landed these unmanned, unwomaned rovers, unpersoned. Incidentally, not only the United States was back in the 70s was using those reflectors to measure the distance to the moon. I recall the French, who actually built the retro reflectors used by the Soviets. They also were doing measurements, so that broadens the conspiracy. And back then, the accuracy based on the equipment available then, they were able to measure the distance to the moon to within something like a couple of centimeters, which was outstandingly good for the time. So more recently, there are measurements being done by Dr. Tom Murphy, University of California, San Diego, using a telescope that's, if I remember right, in New Mexico. I gave a talk on this here at Macomb about 4 years ago, and it's on the YouTube website if you want to see that. I gave a whole hour presentation on that. I'll show you just a couple of slides. The idea is you're firing through this big telescope, you're firing laser pulses from a green laser at these reflectors on the moon, and with enormous precision, timing how long it takes them to come back. This is many pulses going to the moon and coming back at the same time. So I'm just going to cut to the chase that now we can measure the distance to the moon to roughly plus or minus 1 millimeter accuracy. And it confirms that the moon is still slowly moving away from the Earth at about 38 millimeters per year.
Oh, no.
What? Is that a problem?
Well,
Eventually.
won't get as big as a, full moon.
Yeah, we won't have supermoons in
Yeah, there
2
you go,
years.
supermoon.
We'll have more annular eclipses.
No! We won't have as big supermoons.
So anyhow, the point is, this kind of sort of confirms the idea that I talked about last year, that the moon formed much closer to the Earth after the collision with Theia. And initially it would have been moving out much faster because the tidal effects would have been gigantic. Now it's moving out slowly. Now, I have some other, that's as much as I want to do with that stuff, but I do have a few other comments. An awful lot of people at NASA would have to have been in on such a conspiracy, not just at NASA, but people that around the world that were examining lunar rocks and stuff like that, and doing these laser pulse studies. How long could all of those people have kept this quiet? I mean, it's hard for NASA or any branch of the government to keep anything secret anymore.
They were probably threatened with They were probably threatened with death.
Opened about the Soviet space program. Yes, they were able to keep a lid on some things for a while, but not for that long.
Right. It leaked out.
Yeah.
Stuff.
Well, they kept Area 51 quiet thus far.
Yeah, where all the aliens are, right?
Yeah.
That's been kept.
Another point another comment I would have is that NASA technology at the time appears to have been adequate. At least I would say so, to get people to the moon. It was easier to just go to the moon than to fake it and keep it quiet.
Oh, my God.
What would impress me among the conspiracy theorists would be if they published some detailed engineering calculations to show that the Apollo missions could not have made the trip. Show me. I'm from Missouri. Show me. Show me why they couldn't do it.
Conspiracists don't show you anything.
Yeah. But I mean, show me why they couldn't do it. I don't see it. Another thing that I have often thought about is there were a lot of radio transmissions going back and forth between NASA and the spacecraft going to and from the moon and the spacecraft on the surface of the moon. And NASA would have these big radio telescopes pointed at where they were.
All around the world.
All around the world. But not only, but not just NASA. The British and the Soviets had such radio telescopes too. And the Soviets would have liked nothing better than to say that, Houston, we have a problem, right? Your signals aren't coming from where you say they are, right? They would have loved that because they got beat. I raised this with somebody some years back, and he was trying to come up with some rationale for how the Soviets were in on the conspiracy to say that we beat them, right? I think what that illustrates is how far some conspiracy theorists will go to hang on to the conspiracy thing, right? Now, I think some of the people I've talked with who are into that conspiracy stuff, some of them don't have a real science or engineering education at a university level, and they don't know how to judge these things. I watched some of these YouTube videos of the conspiracy theorists, and they can make their case sound convincing to somebody that doesn't know science. I get it. And if you try to talk to them, you can only give them the most intuitive level of reasons for why these conspiracy arguments are wrong, because they don't know science. And I've tried to teach them a little science, and they're not scientists. You can't teach scientists, you can't teach science like that.
And you also have to have a desire to learn it, and they don't.
Yeah.
So.
Yes.
You know, I've watched these programs before, and it seemed like every argument they had, like, I could easily refute without even doing any research. The one that I've always wondered about is they said that they showed a picture of the gloves the astronauts were wearing, and they said that they could never have changed the film, which supposedly they did have several rows of film that they were changing while they were out of the spacecraft. And it could not have possibly been done while wearing those gloves.
They didn't change the film. They used to have backs. Each of those backs used ultra thin 70mm film, and each one could take about 500 pictures on that. And they never changed the film like you do in 35. The Hasselblad, the back fits on, and there's a dark slide slides off, so they never have to touch the film.
I'm sorry, I couldn't hear you.
It's basically saying the cameras and the film that they use, they could take 500 pictures without changing the film.
The back comes off.
Almost
Yeah,
as if
The entire back of the camera comes off.
Yeah. Almost as if they planned to work around the glove problem.
No way! Mike, they couldn't have done that.
So,
you know, they showed a picture of the glove, but they didn't show a picture of the camera. And, you know, it would have been interesting to have them actually demonstrate, you know, here's you trying to change the film and how they didn't do that.
You know, it would take a lot more faith on my part, knowing what I know, to believe that we didn't go to the moon than to believe that we did go.
Just the Soviet reaction alone.
Yeah, yeah.
Awfully tough.
That's
Yeah,
right.
like I say,
That's right.
these are some of the things I've thought about beyond the details of some of these arguments. The other thing is, I couldn't find it, but I saw a video on one of these YouTube websites one time where they showed what appeared to be, here's the lunar surface and an astronaut walking around. And it looked like a real blurry figure of a person steps out and then steps back, and they're saying that was part of the stage crew. I mean, how do I know they didn't fake it?
Yeah.
It was a moon man.
It was the moon man, the man in the moon. Okay, so
That's so funny.
look,
We should have that today.
I'm sure we could get into a lot more things, and I kind of hit it quick on a lot of this stuff. But I'd like to transition for just a couple slides into a somewhat related but different topic. This is, you know, a lot on the moon, right? And what I'd like to go to now is going back to the moon again. This time, not just for a quickie visit, but to plant a colony.
Pitch a Coleman 10.
What?
Pitch a Coleman 10.
I can't
Coleman
understand.
tent.
Coleman is a brand name tent.
Oh, pitching
Campbell.
Coleman.
Coleman tent.
Never heard of it.
A tent. Coleman.
Oh,
Coleman is a brand.
Yeah.
Yeah, let's go tenting on the moon.
Right.
I don't think so, but look, I gave an hour-long presentation, I think it was within the last year, it was called Colonizing Mars, but as part of that presentation, I talked about colonizing the moon. And so I'm just going to show you a couple slides from that dealt with the moon. There's a lot more there. You can go to YouTube, Warren Astronomical Society, Partin, and you'll see the talks I've given listed. Just click on the one about colonizing Mars. Okay, it's there. Whole hour-long talk. I give that talk all over the place. I mean, I gave it to the Michigan Atheists and Humanists Association in Lansing just a month ago. I'm giving it to the regional Mensa group in April. I'm giving it, I hate to bore you, but if you go to the swap meet, I'm one of the speakers, and they asked me to speak about colonizing Mars. So you can be looking at doing something else at the swap meet, right, when I'm doing that, if you already saw that. Although I keep updating it.
Where is that?
That's at Henry Ford College.
Okay.
When is it?
April 7th.
April 7th?
And the
Yeah.
YouTube channel?
Oh, the YouTube channel is just put in the name of this organization,
Okay.
Warren Astronomical Society,
Okay.
and then my last, if you just do that, you'll see all the talks. If you add my last name, you'll see the ones I've given.
Okay.
Okay? So, I think the Soviets would have been all over this thing, going bam, 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 right? I mean, for sure. They sent congratulations. And again, it'd be easier to just go. I mean, get real. Okay, on to the moon. In the future, colonization this time. The technology is now getting to the point where this is just getting there is the easy part. It's living there that's going to be where the challenges are. The technology is just there, easily there now, to get there. This is Shackleton Crater near the moon's south pole. It's big. It's like something like 15 miles in diameter and, I don't know, 2.5, 3 miles deep. And this is near the south pole, so the sun never shines to the bottom of that crater. And so just like on Mercury, where there are craters near its north and south pole, it's always dark and cold down there. And so there's ice frozen down there. We've had, I forget who did it, whether it was us or the Europeans, but had satellites fly over and use equipment to see evidence of ice, lots of ice.
Water ice.
Yeah, water ice,
Mm-hmm.
yeah. The European Space Agency is considering this area for its moon base. There's sunlight on the edges of the crater most of the time. And you can see the Earth at least half the time from the edge. And this is a kind of an artsy idea of what a moon base would look like. I don't like that myself. As I add this comment here to their picture, the surfaces of this habitat had better be thick enough to stop most cosmic rays, or they're going to be sickos. You can watch my presentation on Mars if you want to hear more about that. So, this idea to build some kind of a base on Mars is part of their, that's like step one for moving out into the solar system. The head of the European Space Agency recently said, I think we should go first to the moon and then farther on. And Elon Musk wants to go to Mars so bad he could wet his pants.
And there's a lot of people who like to send them too.
I mean, that's what he wants to do. He is a true believer in getting people not just to Mars, but colonizing Mars.
There's no way to get him back.
He doesn't want to get them back. He has a way to get them back.
I mean, not a good way to get him back.
Well, but
So he wants the rocket back.
look, at this point, I think we're at the threshold where getting people to Mars is very doable soon, and getting them back is at least theoretically possible if they want to come back. The hard part is surviving long-term on Mars. Really hard. And I talked about that a lot, and I keep changing my Mars presentation as I learn more every time I give that talk. But I think it will happen, just not as fast as Elon Musk would like it to happen. President Trump signed a directive 2 months ago telling NASA to focus on getting people to the moon, not to Mars. That doesn't forbid people from going to Mars, but that will mean a lot in terms of, I mean, one of the reasons I favored, some of the reasons for going to the moon first are to get practice on the kind of technologies that you need to survive on other places like the moon and Mars. Do it close to Mother Earth, right? So if something goes bad wrong, you're only about 3 days away. Either get supplies up or get somebody who's sick down or whatever, right? Not a year away or whatever, 6 months away. 6 months if you happen to be at the right time of year when the Earth and Mars are lining up right to get back. Otherwise, you can't get back. When the Earth looks like this bright star, not like that, you know you're way far away, right? You know. So I think is the right decision to learn how to live on the moon first, learn how to do stuff like recycle human waste so you can live on it, you know, drink the water and that kind of stuff. How to grow food, how to build a habitat that you're not going to be exposed to cosmic rays. A worse one that I talk about in the Mars presentation, I mean, the cosmic ray thing, you just put enough stuff on top of you and you're okay. How do you deal with the fact that the gravity, surface gravity on the moon is 6 times less than it is on Earth? Your body will fall apart. It's not quite that bad on Mars, but it's still bad. It's 38% of 1G on the surface of Mars. That's going to be, I think, bad. So I think, well, again, I don't want to try to go through my whole earlier presentation on colonizing Mars. I'm just telling you, those are some of the things that, let's work on those things closer to home. Yeah.
I have a rule of thumb, and the distance to the space station is about 250 miles. The distance to the moon is 250,000 miles. The ratio of those two is 1,000 times farther to the moon than the space station. And if you do a Hohmann transfer to get to Mars, that's 1,000 times longer than going to the moon. So it's about 1,000,000 times harder or longer to go to Mars than the space station. Just a rule of thumb, to give you a practical.
I personally think getting to Mars is not going to be the big challenge. It's living on Mars.
But that's what the distances are.
That's it.
Well, I'm going to stop there. Oh. Thanks for your attention.
Yeah, thank you.
I think we're out of
We got
time.
2 minutes.
Yeah.
Oh, 2 more.
Perfectly
2 more
timed.
minutes. Oh, Q&A.
All right, one more.
There's a lot of talk about mining on the moon. Is there any real proof that there's anything to mine?
I mean, there could be metals, heavy metals like platinum and so forth.
There could be.
Could be.
Meteorites.
There's hydrogen-3, right?
Yeah.
Hydrogen-3 deposits.
Tritium.
Yeah.
But I frankly doubt that anything you're going to mine from the moon is going to pay
Yeah.
for getting there.
Yeah.
But if you can make fuel on the moon, then
Right.
you can, it helps a lot.
Yeah.
So-
Use it to build.
Yeah, and on Mars, you've got a lot of ice, which you have there, but you also have a lot of carbon dioxide in the Martian atmosphere. And with carbon dioxide and water ice, you can make methane and oxygen to use in rockets, or to use in fuel cells to make electricity, or to use oxygen for breathing. And you don't have carbon dioxide, unless there's carbon dioxide frozen down there with the water ice, could be. Yeah,
Mike, did you have a question?
oh, sorry.
Is there final?
The dust on the moon, I don't think they, when they dug their trenches and when they were there, they never hit bedrock. So I don't think there's an official number for how much dust is on the moon. It's just ground up stuff,
Yeah.
even going
Yeah.
down several inches.
Oh, I think that the stone and rock size stuff goes down probably for 100 meters in places. Because it's been pounded by things of various
Because when they looked in the
sizes.
craters too, they don't see any bedrock. When you go to Mars, you see layers.
Yeah, yeah, the geology is
Because it's the
different.
same stuff for a couple feet. So if you take off a foot, it looks the same.
Well, they did missions to the highlands, so they,
It depends on where you are on the moon. It's not uniform.
Remember, the first couple of missions were to the Maria.
All right, Jerry, last question.
Well, I'd like to point out that if you want to get resources from space, it's a lot cheaper to mine than asteroids than the moon, because the moon has gravity that you have to defeat to get it back off the surface. So it's a lot easier to get to an asteroid mine and bring stuff back.
If you're using a robot to do it, yeah. One problem with doing it on an asteroid is there is no gravity, therefore stuff floats away.
Oh. Gotta use that stickum tape.
I mean, I think having some gravity can, there's advantages to zero gravity, but there's advantage to that gravity too, especially if you have people involved.
Okay.
All right, well, thank you all for coming. Jim? you wanna-